Welcome to the Explainer. You've probably talked to a chatbot, right? But what does it actually take to turn one of those into a true agent? Something that can think for itself, make plans, and actually do things on its own. Today, we're going to dig into the blueprint for building an AI mind, and we're going way beyond the hype.
Okay, so let's start with this really great analogy from the paper, Advances and Challenges in Foundation Agents. It tells us to think about large language models, LLMs like ChatGPT, as just the engine. It's got all this horsepower, right? But an engine just sitting on the floor, it doesn't go anywhere. It's just one really powerful part of a much, much bigger machine.
So that's the big question for today, right? If the LLM is the engine, what else do we need to build the rest of the car? What does it take to turn all that raw power into a complete autonomous agent that can actually get up, look around, and do things in the world?
So where do you even start? Well, to figure out what's missing, researchers are looking at the best example we've got, the human brain. Now, this isn't about perfectly copying biology, but more about using it as a kind of functional blueprint.
And the key word here is functional. The goal isn't to build a squishy biological brain. No, it's about learning from the brain's super efficient modular design. You know how different parts have their own special jobs, like seeing, remembering, or planning, but they all work together perfectly.
Okay, so if we're using the brain as a blueprint, what are the actual parts we need to build? Let's break down the essential components of an agent's mind.
First thing you need, senses, perception. Think about it. A model that only sees text is basically blind and deaf. For an agent to work in the real world, or even just a messy digital one, it has to be able to see, hear, and understand its surroundings.
And this is where things get really interesting. The researchers we're referencing, they actually grade these skills. Visual perception, like just recognizing a picture of a cat, that's at L1, meaning it's well developed. It's like an A+ on the report card. But combining sight and sound and touch all at once to understand the world like we do, that's a huge challenge, sitting in L2, or only partially developed.
Okay, so the agent can see and hear, now what? It needs to be able to do things. That's action. It's not enough to just think about something or write about it. A real agent has to be able to click buttons, use software, move a robot arm, actually change things in its environment.
And yep, we're back at level L2 again. Agents are getting pretty good at using digital tools, say booking a flight online. But when it comes to complex physical stuff, like a robot trying to assemble some IKEA furniture, yeah, their coordination is still pretty clumsy compared to ours.
All right, this next one, this is a biggie. Memory. A normal LLM's memory is basically just its short-term chat history. Once that conversation's over, it's like it never happened. A true agent needs long-term memory to learn from what it's done before and, have a consistent personality over time.
And this is why it's labeled L3, basically unexplored territory. There's this wild problem in AI called catastrophic forgetting. It's where, when an AI learns something new, it can just completely wipe out what it knew before. So building a stable, lifelong memory is a massive, massive challenge.
Now we get to the part where that LLM engine really gets to flex its muscles, planning and reasoning. This is the thinking part. And it has to be about more than just spitting out a sentence that sounds right. It's about breaking down a big goal into smaller, logical steps and making choices before it acts.
So why only L2? Well, while these models are amazing at following a set of steps for a known task, if you throw them a curveball, a totally new problem, or a situation with tricky trade-offs, that's where they still kind of struggle to plan flexibly like a human can.
Okay, so we've got all these pieces, right? Perception, action, memory, planning. But just having the parts isn't enough. They're like a pile of car parts on the garage floor. The real magic is how you put them together.
And it's not a simple assembly line. These parts all connect into this constant looping cycle. It's a feedback loop. And this is the secret sauce that makes an agent truly smart and adaptive, letting it learn on the fly. So check this out. It all starts when the agent perceives what's going on around it. Then it stops and thinks. It figures out what just happened and plans what to do next. Then it acts, which changes the world. And the instant it acts, the world changes. And guess what? The whole cycle starts all over again. Repeat. This loop is what drives everything.
All right, we've got the blueprint, we've got the feedback loop. So what's next? What happens when we get really good at building these things?
And the takeaway is pretty incredible, really, as each one of these individual parts gets better and better. Sharper senses, longer memory, smarter plans. The agents we build are going to become dramatically more capable.
We're talking about a shift from AI as a simple tool you command to AI as a partner that can work alongside you.
And this opens up some really mind-bending possibilities. We're talking about agents that can self-evolve, literally rewriting their own code to get better. Or even agent societies, where teams of AIs work together on problems too complex for any single one. But, and this is the big one, intrinsic safety. This is the absolute #1 challenge, making sure these powerful systems stay aligned with what we humans actually want.
And that really brings us back to the most important point of all. Why are we even doing this? The goal isn't just to build a cool piece of tech for its own sake. It's about making sure these powerful creations are safe, that they're beneficial, and that they ultimately help us, augmenting our own abilities.
So I'll leave you with this. As we get closer and closer to building agents that can actually learn and grow on their own, the question really starts to shift. It's no longer just a technical problem of if we can pull it off. The real question, the much, much harder one, is how are we all going to coexist with them?